See the power of mathematics. So we have different polygons. This is a triangle, this is a square, this is a pentagon, this is a hexagon, and if you increase the number of sides, what will happen? This polygon will tend to a circle. Now we are interested in the magnetic field at the center of each polygons. Okay, this is n equal to 3, 4, 5, 6, and this is n tends to infinity. Now we know that for a circle, the magnetic field at the center is mu 0 I by 2s, and as far as this circle is concerned, if the current is it's like this, it's coming out of the plane of the board. Same for all these. Now what I want to show is, I want to find magnetic field at the center of a polygon which has n sides, and then what I will do is make this n tends to infinity, and I will show that that will match this. It's very interesting. Let's see how to find it. Now what is the magnetic field of a line segment? Suppose at this point, at the symmetric point, if this angle is alpha and this angle is beta, technically alpha equals to beta, so magnetic field B at this point, if this current is I, the magnetic field is into the plane of the board, so that means in this direction. So it's mu 0 by 4 pi I over s times cos of alpha plus cos of beta. So technically, if alpha is equal to beta, so then it is mu 0 by 4 pi I by s cos of alpha times 2. So 2 cos alpha. Okay, 2 cos alpha. Now if you think that this is the side of an n-sided polygon, suppose it is like this, it is like this, it's going like this. So this is the side of n-sided polygon. What? So this is the, let me write, n-sided polygon side. Okay. So what we need to find is, we need to find alpha and beta. How to do it? Very simple. You extend this. Now this is the exterior angle, correct? If this is the exterior angle, so let me draw it properly. So this should be beta, I'll tell you why. Now this is the exterior angle. So we know that the sum of exterior angles is 360 degree or 2 pi radians. So I am referring it as xi n. As for example, this is a hexagon, right? So here I am referring as xi 6. So what will be xi 6? Here xi 6 will be 2 pi by 6, right? Because it has 6 sides. So here xi n will be 2 pi by n, correct? 2 pi by n. Then from here you check this hexagon. How do you find this angle? In this hexagon, what we need to do is, we need to find the magnetic field for this section. That means you need to find this angle, this alpha and this alpha, right? Because it's an isosceles triangle. So here what will be alpha? Because if this is alpha, this is also alpha by symmetry. So here alpha will be pi minus xi 6. So pi minus xi 6 by 2. So that is pi minus 2 pi over 6 by 2. So that's logically alpha. Now what if you take this alpha and if you plug it in the expression for the expression for the line segment here, and you multiply with 6 for the 6 sides, you get the magnetic field at the center. Now what we shall do is, we shall find the magnetic field for an n-sided polygon. See, this is an n-sided polygon. Now here xi n is 2 pi over n. So what will be, this is alpha, this can be beta as well, it's not a problem because alpha equals to beta. So here what is alpha? alpha is equal to, you subtract subtract xi n from pi and then you divide it by 2. So, it is pi minus 2 pi by n by 2. So, that is pi by 2 minus pi by n. So, that is alpha, right. Now, what you need to do is you take this alpha and you plug it in here. So, b is, so what is b? B is, remember you have to multiply it by n. So, mu 0 by 4 pi I by s, then you multiply with n, then 2 is already there, then cos of alpha is this, pi by 2 minus pi by n, right. See, this is the magnetic field for the n-sided polygon. So, this is the magnetic field for the n-sided polygon. Now, if you expand this, cos A minus B is cos A cos B plus sin A sin B. So, cos A cos B is cos pi by 2, it will be vanish. So, plus sin A sin B, sin pi by 2 is 1. So, it will be just sin pi by n. So, this is mu 0 by 4 pi I by s times 2n times sin over sin pi by n. Now, if I arrange this a little bit, so mu 0 by 4 pi, then I by s, then sin pi by n, in the denominator you just, in the denominator you bring this pi here. So, remove this pi here and bring it here pi, and this n you divide this by n, fine, and you keep the 2 here. See, this n, if you bring it up, it comes here, and this pi I have taken it from here. It's very simple. Now, what I need to do is, I need to make this n tends to infinity. So, if limit n tends to infinity, then pi over n tends to 0, right. So, that means sin 0 by 0 form. So, that is 1, correct. So, that is mu 0 I 2 by 4s. This gets cancelled, it is 2. So, it is mu 0 I by 2s. So, it matches this. See the power of mathematics. You can, if you can apply it confidently, you will get the result. Believe in the mathematics, she will never let you down. Thank you very much.